Picture the ocean as a single enormous machine, quietly running underneath every headline about heat waves and hurricanes and droughts that shows up in the news throughout the year. Most of the time, that machine hums along in the background, unnoticed, its influence blended into everything else happening at the surface. Every once in a while, though, it shifts into a configuration extreme enough that scientists can't help but notice, can't help but measure it obsessively, can't help but start comparing it to the handful of times in recorded history it's done something similar. That's exactly where the ocean sits right now. There's a number sitting in a no-way database right now that most people will never see, and it says something most people don't expect: 69%. That's the probability federal forecasters have assigned to this year's El Niño reaching what they specifically call historic strength by the end of the year, a level that would beat every single El Niño ever recorded since formal tracking began in 1950. Federal climate agencies don't reach for the word historic casually. When they do, it's worth understanding exactly what they're looking at. This isn't a story about one storm. Storms come and go within days, and whatever they leave behind gets cleaned up, rebuilt, and mostly forgotten within a season. What's actually building right now is something else entirely. A shift in the deep ocean atmosphere machinery that decides, for months at a stretch, which parts of the country flood and which ones dry out, which regions bake under relentless heat, and which ones get a break, and even which parts of the Atlantic Ocean spin up hurricanes and which stay unusually calm. That machinery has a name. It's called El Niño, and the version of it currently developing in the Pacific isn't behaving like anything scientists have measured before. Here's the mechanism, in plain terms, because it explains everything that follows. El Niño is the warm phase of a larger naturally recurring cycle, centered on a specific stretch of the tropical Pacific Ocean. Normally, steady trade winds blow east to west across that stretch, piling warm water up against Asia and Australia, while cooler water wells up along South America's coast. El Niño happens when those trade winds weaken or reverse, letting that pooled warm water slosh back east, the way tilting a bathtub sends water rushing toward the opposite wall. That shift doesn't stay contained to the ocean. It reorganizes where the atmosphere generates rising and sinking air across an enormous stretch of the globe, dragging the jet streams that steer weather systems into entirely new positions. That's the actual physical thread connecting a patch of warm water near the equator to flooding in California, drought in Southeast Asia, and shifts in hurricane behavior across the Atlantic, all at once, thousands of miles from where the change actually originates. El Niño itself isn't rare. It cycles through roughly every 2 to 7 years. What's rare is when it crosses into super El Niño territory, sea surface temperatures in the key monitoring region climbing at least 2 degrees Celsius above average, sustained for months. That threshold has only been crossed a handful of times since reliable record-keeping began. 1982 into 1983, 1997 into 1998, and 2015 into 2016. Each one reshaped global weather so severely that meteorologists still use them as benchmark comparisons decades later. That's the exclusive club this year's event is now on track to join, and according to a growing body of evidence, potentially not just join, but lead. NOAA officially declared El Niño's arrival back in June. What's happened since has caught even experienced forecasters off guard. The event reached moderate strength weeks ahead of its typical schedule, and by early August, sea surface temperatures had already climbed roughly 1.5 degrees Celsius above average, firmly into strong territory, well before the point in the season when these events usually even approach their peak. 3 separate forecasting agencies, using different modeling approaches, NOAA in the United States, the European Center for Medium-Range Weather Forecasts, and Australia's Bureau of Meteorology, have all independently converged on the same striking projection: a peak somewhere between 3 and 3.5 degrees Celsius above average sometime around November. If that verifies, it would be the strongest El Niño ever formally recorded, surpassing every event on the books, including the 2 that already carry the super designation. What makes this even more remarkable than the projected peak itself is the pace getting there. Researchers who track these events year over year pulled the daily temperature data going back to 1982 and lined this year's warming curve up directly against the 2 previous record holders. The comparison wasn't close. At the same point in the season, 1997 sat at roughly 1.6 degrees Celsius above average. 2015 sat at about 1.3. This year is outrunning both earlier in the season than either one managed, and because El Niño events typically keep intensifying through fall before finally peaking between November and January, that head start suggests considerable additional strengthening is likely still ahead. There's a worthwhile technical nuance in how scientists are measuring this comparison. For decades, El Niño strength has been tracked using the Oceanic Niño Index, which compares current temperatures against a fixed historical average. But because the entire global ocean has already warmed due to the broader climate trend, some researchers argue that comparison overstates how unusual any given year looks. since the whole ocean runs warmer than it used to regardless of El Niño. A newer measurement, the relative oceanic Niño index, instead compares the monitoring region against the rest of the tropical ocean at that same moment. Using the older index, this year blows every previous comparable year out of the water. Using the newer, more conservative one, it's running roughly neck and neck with 1997. Either way the conclusion holds, this is one of the 2 or 3 strongest starts to an El Niño ever documented. And by the more aggressive measurement, it may already stand alone. It's also worth understanding what kicked this event into such an aggressive trajectory in the first place, because it wasn't random. Earlier this year, researchers tracking Pacific wind patterns identified a series of unusually powerful westerly wind bursts, brief but intense reversals of the normal trade wind flow, that pushed an especially large pool of accumulated warm water directly toward the equator. The meteorologist who flagged this pattern pointed to its closest historical parallel without hesitation, a nearly identical wind event recorded in early 1997, the exact precursor to what had been, until now, the strongest El Niño of the 20th century. So why should any of this matter to someone who's never once thought about ocean temperatures 1,000 miles offshore? Because unlike a storm, El Niño is one of the most powerful naturally occurring drivers of global weather on the planet, capable of reorganizing rainfall, temperature, drought, and storm behavior across multiple continents simultaneously for months at a stretch. A genuinely record-strength super El Niño doesn't just nudge those patterns slightly, it can overwhelm them. And here's the detail that genuinely separates this event from every previous super El Niño on record, the specific reason climate scientists keep returning to it as fundamentally different, not just a bigger repeat of something familiar. This El Niño isn't developing inside a climate system that resembles the one it developed inside during any previous occurrence. Global average temperatures are already sitting more than 1.4 degrees Celsius above pre-industrial levels, a baseline that simply didn't exist in 1982, 1997, or 2015. Climate scientist Daniel Swain, who studies exactly this kind of compounding interaction, put it about as plainly as scientists allow themselves in public commentary. Humanity has never before experienced a strong or very strong El Niño arriving on top of a global baseline this warm. This is genuinely uncharted territory, not because El Niño itself is new, but because the conditions it's now layering onto have never existed before in the era of modern climate measurement. That distinction is exactly why a record-strength El Niño arriving on a record-warm planet deserves to be called a pattern that could shock the country, rather than just another seasonal update. Even without that extra warming layered underneath it, previous super El Niño events were already devastating enough. The 1982 and 1997 events were described by scientists living through them as incredible flood years across parts of the Americas, and the 1997-98 event alone is estimated to have caused between $35 and $45 billion in global damage. A record-strength event now arriving on an already elevated baseline has the potential to push rainfall extremes, heat extremes, and drought into territory the older historical comparisons may not fully capture. There's an economic thread running underneath all of this too, separate from the raw meteorology. El Niño's influence doesn't stop at rainfall totals. It ripples into food prices, agricultural output, and insurance markets worldwide. Previous strong events have been tied to reduced crop yields across Southeast Asia and Australia, where drought strains rice and wheat production during the exact growing seasons those events tend to overlap with. Coffee-growing regions across Central and South America have historically seen yield disruptions tied to El Niño-driven rainfall shifts as well, occasionally showing up months later as a genuine influence on global commodity prices. None of that is guaranteed to repeat with identical severity this time, but it's part of why organizations well beyond weather agencies, agricultural economists, insurance underwriters, global commodities traders are tracking this event's development with the same intensity meteorologists are. The effects aren't uniform across the country, and understanding that variation is part of what makes this a genuinely national story. Across the southern United States, strong El Niño events have historically brought wetter than normal conditions from the southeast through the Gulf Coast into the southwest, as the Pacific jet stream shifts south and funnels in extra moisture. Genuinely useful for drought-stressed reservoirs, but also carrying real flood risk, particularly in California, where the 1997-98 event triggered atmospheric river storm sequences capable of catastrophic flooding and landslides. It's worth being honest that this signal isn't guaranteed, though. The 2015-16 Super El Niño reached historic strength in the open Pacific, but notably failed to deliver the wetter Southern California winter that had been widely expected. A reminder that even a record-strength ocean event doesn't automatically translate identically on land. Meanwhile, the northern tier of the country and much of Canada typically trend milder and drier during a strong El Niño winter, as that same jet stream shift pulls storm systems and cold air away. Farther out across the Pacific, Indonesia and northern Australia have historically faced severe agricultural drought during previous Super El Niño years, while parts of East Africa have seen the opposite, unusually heavy flooding, a pattern documented in both 1997-98 and 2015-16. And then there's the Atlantic hurricane season, which connects directly to something already quietly playing out this year. A strong El Niño significantly increases wind shear across the tropical Atlantic. Winds at different altitudes blowing in different directions, strongly enough to tear apart developing storms before they can organize. That's a direct, well-documented mechanism, and it's part of the specific reason this year's Atlantic season has run so unusually quiet, with named storm formation lagging well behind typical pace. The same oceanic pattern pushing potentially record heat and rainfall extremes elsewhere on the globe is, at the same time, actively suppressing an entirely different hazard. There's also a planet-scale consequence tied directly to why forecasters reached for the word historic in the first place. Even without El Niño's influence, 2026 was already tracking as likely to rank among the 5 hottest years ever recorded. El Niño events reliably add an extra boost of warmth to global averages on top of the underlying trend, because the additional ocean heat released into the atmosphere doesn't stay contained to regional patterns. It measurably raises the planet's average temperature for the year or two following the event's peak. Multiple researchers have specifically flagged the realistic possibility that this event, layered onto an already warming planet, could push 2026 or 2027 into the position of hottest year ever recorded, surpassing the record set in 2024. It's worth adding some historical weight to why scientists take the extreme end of this seriously. Before modern record keeping, researchers have identified evidence of a Super El Niño in 1876, connected by historians to a catastrophic global famine estimated to have killed as many as 50 million people as failed monsoons devastated agriculture across multiple continents at once. That's an extreme historical outlier from an era without today's agricultural resilience, global food networks, and early warning systems. But it's a sobering reminder of how far-reaching this phenomenon's consequences can become at their most extreme. So where does the honest, grounded version of this story actually land? Multiple independent, credible forecasting authorities are all currently projecting that the pattern developing in the Pacific right now is genuinely on track to become the strongest El Niño ever measured, arriving specifically at a moment when the global climate baseline it's interacting with is warmer than during any previous such event in recorded history. That combination, record pace, record potential peak, unprecedented baseline warmth, is exactly why scientists have reached for language they don't use lightly. It's also worth being honest about the uncertainty that remains, because that honesty is what separates a credible warning from an exaggerated one. Forecasts made months ahead of an event's peak still carry real uncertainty, even with strong model agreement. The 2015-16 event is a direct example of historic ocean temperature strength that still failed to deliver one of its most anticipated regional impacts. Exactly how much rain falls where, and exactly how severe any particular drought or flood ends up, remains genuinely difficult to pin down this far in advance, even when the underlying oceanic signal is this clear. What can be said with real confidence is this: the oceanic pattern building right now is developing faster and trending toward a higher potential ceiling than any El Niño in the modern historical record. It's arriving during a climate meaningfully warmer than during any previous such event, a combination multiple climate scientists have specifically called unprecedented. Its influence is already measurably reshaping weather across the country this year, from an unusually quiet hurricane season to shifting rainfall outlooks across the South. And its full effects are expected to intensify further as it builds toward its projected peak around the end of the year. For anyone living in a region historically sensitive to El Niño, flood-prone California in the Southwest, drought-vulnerable agricultural regions, or Gulf Coast and Southeast communities that could see an active, wetter pattern build through fall and winter, this is a genuinely useful moment to engage with regional preparedness guidance specific to your own area, rather than treating this as a distant story with no bearing on your own planning. There's a broader lesson in all of this, too. Natural cycles like El Niño have always existed, long before anyone had satellites or supercomputers to track them. What's genuinely different about this particular moment isn't the cycle itself. It's the environment that cycle is now unfolding inside. A climate system already running warmer than at any point in the instrumental record doesn't experience natural variability the same way it used to. It experiences that variability from a higher starting point, which means the peaks reached during naturally warm phases increasingly carry the potential to exceed anything previously recorded. Not because the cycle has changed in character, but because the baseline it keeps cycling on top of keeps quietly climbing. There's one more thing worth saying before wrapping up, because it changes how a story like this should actually be absorbed rather than just heard once and forgotten. A single storm offers a clean, satisfying arc. It builds, it strikes, it passes, And within days, the story is essentially over. A pattern like this one doesn't offer that same tidy resolution. It's going to keep showing up in different forms across different regions for months, sometimes in ways that don't obviously trace back to a headline about ocean temperatures from back in August. A wetter than normal winter in one state, an unusually quiet hurricane season along the Gulf, a drought tightening its grip on farmland on the other side of the planet. Each of those, taken alone, might look like an isolated, unconnected piece of news. Understanding the pattern underneath all of them is what turns a scattered collection of headlines into one coherent story about how the planet's weather machinery is behaving differently this year than it ever has before. That's the real story sitting underneath everything else here. A climate pattern scientists have tracked for well over a century just sent a signal strong enough and moving fast enough that the people whose careers are built around interpreting it reach for words like historic and unprecedented, not as marketing language, but as the most technically accurate words available. It's not just a storm. It's the underlying machinery behind an entire season's worth of storms, droughts, floods, and heat waves, shifting into a configuration the modern climate record has never once produced before. And whether the coming months confirm the most extreme end of these forecasts or land somewhere more moderate, the signal driving this story is one worth understanding clearly, exactly as the scientists tracking it, in real time currently understand it themselves.